Okay, the next problem asks us to solve the system by graphing. So we are given two equations. L sub 1 stands for line 1 and L sub 2 stands for line 2. If I'm trying to graph 2x minus y equals negative 3, I'm going to solve for y. So what I'm going to do is I'm going to move the negative y over to the right as y, move the negative 3 over as positive 3 to the left. Y equals 2x plus 3. M is 2, B is 3. If I want to graph x plus y equals 6, I'm going to solve for y by subtracting x. Y equals negative x plus 6. 6 is the y-intercept. The number in front of the x is negative 1, and that's my slope. If I want to graph line 1, y equals 2x plus 3. Okay, if I want to graph line 1, I start at 3. On the y-axis, I put a dot there, and a slope of 2 is really 2 over 1. I go up 2 and over 1 and put a dot. Okay? There's line 1, right here. If I want to graph line 2, which I haven't labeled, but what I'm running along is line 2, I start with B. B is 6, so I put a dot on the y-axis at 6, a solid dot. Slope is negative 1. That's really negative 1 over 1, so I go down 1 over 1. I go down 1 over 1. Draw my line. And where did the two lines intersect? Well, I have my cursor right on their point of intersection. They intersect at the ordered pair 1, 5. Now, solving by graphing is a beautiful method for seeing what's happening. However, you don't want to make this your main method because, first of all, it takes time. And secondly, what if the point weren't pretty? Like, for example, this turned out really nice. 1 and 5 are both integers, but what if the point of intersection was something like 5/3 comma negative 11/5? No way you'd see that from a graph. So, you need to learn other methods. Here's a system. X plus y equals 5 and x minus y equals 3. Here's our system. I'm going to teach you how to solve this by the elimination method. Now, see there's a positive y and there's a negative y? If we add them together, they eliminate. X plus x becomes 2x, 5 plus 3 becomes 8, 2x equals 8, therefore x equals 4. Look at how fast we got the answer to x. X is 4. Now, you're not done because you still need to find y. Well, I can take either of these two equations and plug in for x and solve for y. Let's take the top equation. X plus y equals 5. If I replace x with a 4, 4 plus y is 5. If I subtract 4 from both sides, y is 1. If I write that as an ordered pair, it's the ordered pair 4, 1. This is a consistent system because there's one answer. There's at least one answer, so consistent. And it's an independent system because you're picturing, if you picture the three pictures I showed you earlier, you're picturing the first cross. These two lines are pretty independent. They only meet one time. That's pretty, they're living a life of independence, okay? Now, this next system that you're looking at here, what's happening in this problem or in this system? You can't just add things together like you did before because nothing would eliminate. So you kind of have to pick a victim. I chose the x's as a victim. Now, this x that I'm on right now says 2x. If I made the top equation read negative 2x, then the x's would disappear. I can do that by multiplying the top equation by negative 2 and leaving the bottom equation alone. When I multiply the bottom equation by -2, it becomes -2x plus 2y equals -8. When I leave the bottom equation alone, it stays alone, no changes. Now, I was trying to eliminate the x's, but, surprise, I've also eliminated the y's. I wasn't counting on that, but I did. 0 equals -4. Now, I asked my students in class today, when is 0 equal to -4? They said never. That's correct. What two kind of lines never cross? Parallel lines. There you go. So now we know we're in that second picture. What's the solution set? It's the empty set, or some students like to write no solution. This is called an inconsistent system because it has no answers. And it's also independent because two lines never go to lunch together. Got it? Okay. Now, 2x plus 4y equals 2, -x minus 2y equals -1. Okay, this time, notice what's happening. Let's say I want to eliminate the x's again. The top x is a 2x, the bottom x is already just a -x. If I multiplied the bottom equation by a 2, that would turn this into a -2x and it would cancel with the top, or eliminate. So the top equation, there's no change. When I multiply the bottom equation by 2, I get -x minus 2x minus 4y equals -2. Uh-oh, 0 equals 0. Okay. When is 0 equal to 0? Always. When do two lines always touch? When they're the same line. So you have that third picture going on. It's consistent because there's at least one solution, and this is that dependent system because one line's on top of the other. Your answer can be written one of two ways. Do not write all real numbers. This is not a number line you're dealing with here, okay? You're in two dimensions. So your answer can either say all points on the line, or you can write it in set builder notation as the set of x comma y, which is an ordered pair, such that, and then you write the equation of the line. I've told my students they're allowed on a test for the answer to write all points on the line, or they can write the set builder notation. What I won't accept from them is all real numbers. That's not a correct answer. You're in two dimensions, you're giving me ordered pairs as answers. All right, here's another system. In this system, notice how easily I can eliminate the x's. If I multiply the top equation by -1, that will put a -6x there, and that of course will eliminate with the bottom one. So the top equation becomes -x plus y equals -47. 6x plus 7y equals 7. When I combine these, I get 8y is -40, y is -5. Now, to get x, I'm going to go to either equation, but let's say I pick the top one. 6x minus a -5, that's what y is, equals 47. 6x plus 5 is 47. When I subtract 5, 6x is 42. When I divide by 6, x is 7. Our solution set is the ordered pair 7, -5. That's like the x, that's like your first picture, two lines that meet in one location, one ordered pair. This is a consistent system and it is also independent. Okay. And I'm going to pick up this next one on the next movie.